The sun is breaking the rules. For decades, we thought we understood the heartbeat of our star. We built complex mathematical models, launched multi-billion-dollar satellites, and convinced ourselves that we could predict its temper tantrums with surgical precision. But right now, 93 million miles away, something unprecedented is happening. Solar cycle 25 was never supposed to be like this. The experts at NASA and the National Oceanic and Atmospheric Administration predicted a quiet, underwhelming decade for our sun. They told us to expect a repeat of the weak activity we saw in the previous cycle. They were dead wrong. Instead of a slumbering giant, we are witnessing a cosmic awakening that is shattering every forecast on the books. Sunspot counts are skyrocketing, massive flares are erupting with terrifying frequency, and the very magnetic fabric of our star is twisting into a chaotic knot that defies our best simulations. This isn't just a scientific curiosity, it is a shift that could fundamentally alter our way of life on Earth. If you find these mysteries of the cosmos as gripping as we do, please subscribe to the channel to stay updated on the latest discoveries. Now, let us begin our journey into the heart of the fire. To truly grasp why the sun is acting so strangely, we have to look at the history of how we track its behavior. Since the middle of the 18th century, humanity has documented the waxing and waning of solar activity in roughly 11-year intervals. We call this the solar cycle. It is a violent, beautiful dance of magnetism where the sun's north and south poles eventually flip places, creating a period of maximum chaos in the middle of the transition. But solar cycle 25, the one we are in right now, is behaving like an outlier. It officially began in December of 2019, and the consensus among the world's leading heliophysicists was that it would be a dud. They predicted it would be one of the weakest cycles in 100 years. Yet by early 2023, the sun had already surpassed the peak activity levels of the entire previous cycle. We are seeing sunspot groups so massive they could swallow the Earth several times over, visible even through simple eclipse glasses. These dark islands of intense magnetism are the breeding grounds for solar flares and coronal mass ejections. When these eruptions occur, they hurl billions of tons of superheated plasma into the vacuum of space at millions of miles per hour. We are no longer just looking at pretty lights in the sky. We are looking at a direct threat to the electronic foundation of our global civilization. The fundamental mystery lies in the Terminator, not the movie character, but a recently discovered solar phenomenon that many scientists believe is the reason our predictions were so far off. For a long time, we thought solar cycles were independent events, beginning and ending neatly every 11 years. But new research suggests that solar cycles actually overlap. The magnetic bands of the previous cycle are often still present when the new cycle begins. A Terminator event happens when the magnetic bands from the old cycle finally meet at the equator and annihilate each other in a massive burst of magnetic energy. This acts as a starting gun for the new cycle, causing it to ramp up with incredible speed and intensity. It appears that the Terminator for cycle 25 happened much sooner than expected, uncorking the sun's energy like a shaken bottle of champagne. This explains why we are seeing X-class flares, the most powerful category of solar eruptions, happening months and even years before they were scheduled to appear in our models. We are currently navigating uncharted territory, watching a star perform in a way that our modern technology has never had to endure before. We have to remember that our modern world is incredibly fragile. The last time the sun truly showed its full power was in 1859, during what is now known as the Carrington event. Back then, the most advanced technology on the planet was the telegraph system. When a massive coronal mass ejection slammed into Earth's magnetic field, it created a geomagnetic storm so powerful that telegraph lines sparked, setting offices on fire and giving operators electric shocks. Auroras were so bright in the Rocky Mountains that gold miners woke up and started preparing breakfast, thinking it was morning. If a Carrington-level event were to hit us today, we wouldn't just lose some telegrams, we would lose everything. Our entire world runs on a delicate web of high-voltage power grids, orbiting satellites, and undersea fiber optic cables. A direct hit from a super flare could induce massive electrical currents in our power lines, blowing out giant transformers that take years to manufacture. We could be looking at months or even years of blackouts across entire continents. This isn't science fiction, it is a statistical certainty that happens every few centuries. and the sun's current erratic behavior suggests we might be closer to that moment than we think. The danger isn't just on the ground, it is in the silence of space. Right now, there are thousands of satellites orbiting our planet, providing everything from GPS navigation to high-speed internet and weather forecasting. When the sun emits a massive burst of radiation, it heats up the Earth's upper atmosphere, causing it to expand outward. This creates extra drag for satellites in low Earth orbit. We saw a terrifying preview of this in early 2022, when a relatively minor solar storm caused 40 Starlink satellites to fall out of the sky and burn up in the atmosphere. They simply couldn't fight the extra friction. During a major solar maximum, like the one we are approaching, the risk to our orbital infrastructure grows exponentially. If we lose GPS, the global supply chain collapses. Planes can't fly, ships can't navigate, and even the timestamps on our financial transactions, which rely on atomic clocks and satellites, would fall out of sync, potentially crashing global markets. The sun is reminding us that while we may feel like the masters of our world, we are actually living in the extended atmosphere of a volatile star. Scientists are now racing to understand the solar interior to prevent a technological catastrophe. One of the greatest enigmas is the solar corona, the sun's outer atmosphere. For some reason, the corona is millions of degrees hotter than the surface of the sun itself. It's as if you walked away from a campfire and found that the air 20 feet away was 100 times hotter than the flames. This defies basic thermodynamics, and it is the key to understanding how solar winds are accelerated to such terrifying speeds. To solve this, we sent the Parker Solar Probe, a spacecraft protected by a cutting-edge carbon composite shield, to touch the sun. It is currently flying through the outermost layers of the solar atmosphere, closer than any object in history, sending back data that is rewriting our textbooks in real time. What it's finding is a chaotic environment of switchbacks, rapid flips in the magnetic field that act like whips, lashing energy out into the solar system. These switchbacks might be the engine behind the sudden, violent bursts of activity we are seeing today. In May of 2024, the world got a wake-up call. A series of massive eruptions led to the strongest geomagnetic storm in over 2 decades. People as far south as Florida and Mexico saw the northern lights. While the world marveled at the purple and green skies, engineers behind the scenes were panicking. High-precision GPS systems used by farmers in the American Midwest for automated planting suddenly failed, forcing them to stop work during a critical window. Power grid operators had to frantically reroute electricity to prevent surges from damaging infrastructure. We survived that storm without major casualties, but it was a shot across the bow. It showed us that even a strong storm, which is still significantly weaker than a Carrington event, can disrupt the modern economy in ways we hadn't fully prepared for. The sun is currently peaking toward its maximum, which is expected to last through 2025 and into 2026. This means the most dangerous window is just beginning. One of the most unsettling aspects of the current solar cycle is the behavior of the sun's poles. Usually the magnetic flip is a somewhat orderly process, but this time the magnetic fields are looking messy. The North Pole and South Pole of the sun aren't weakening at the same rate, which is creating an unbalanced magnetic environment. This asymmetry could be leading to the strange events we've been observing, including unusually long-lived solar holes, regions where the magnetic field opens up, allowing a constant stream of high-speed solar wind to pour out toward Earth for weeks at a time. These streams don't need a flare to cause trouble. They can buffet our magnetosphere and cause persistent space weather that wears down satellite electronics and stresses power grids over long periods. It is like a constant environmental pressure that we are only just beginning to measure. As we look toward the next few years, the big question remains, is this the new normal? Some researchers believe we are seeing the end of a long period of solar calm that lasted for most of the 20th century. We may be entering a new era of high solar intensity, similar to what was observed in the late 1800s. If that is the case, we have to rethink how we build everything. We need hardened power grids that can handle massive induced currents. We need satellites with better propulsion systems to fight atmospheric drag. And most importantly, we need better early warning systems. Currently, we only have about 15 to 30 minutes of guaranteed warning between the time a solar storm hits our deep space monitors and the time it hits Earth. That isn't enough time to safely shut down a global power grid. We are essentially playing a high-stakes game of cosmic roulette, and the sun has just doubled the number of balls in the wheel. The mystery of our star is far from solved. Every time we think we have pinned down a rule, the sun breaks it. It reminds us of our place in the universe, a tiny, fragile blue marble orbiting a colossal nuclear furnace that we cannot control. The anomalies of solar cycle 25 are a gift to science, providing a wealth of data that will help us protect future generations. But for those of us living through it, it is a period of high tension and awe. We are watching the very source of all life on Earth enter a phase of unpredictable fury. Whether it results in a spectacular light show or a total technological reset remains to be seen. But one thing is certain, the sun is no longer the predictable neighbor we thought it was. It is a dynamic, evolving, and at times, dangerous entity that demands our full attention. As we continue to monitor the sunspots and the flares, we are forced to realize that our survival depends on our ability to listen to what the sun is telling us. It is speaking to us through magnetism and light, warning us to prepare for a future where space weather is just as important as the weather on the ground. The sheer scale of the energy we are talking about is hard for the human mind to grasp. A single mid-sized solar flare releases as much energy as millions of hydrogen bombs exploding at the same time. When the sun is in its maximum phase, it can release several of these a day. We often think of space as a cold, empty void, but it is actually a roaring ocean of radiation and magnetic fields. The Earth is like a small boat in that ocean, protected only by the thin, invisible shield of our magnetosphere. But even shields have their limits. When a solar storm is strong enough, it can literally peel back the Earth's magnetic field lines, allowing high-energy particles to rain down into the atmosphere. This process, called magnetic reconnection, is one of the most violent events in near-Earth space. It is what fuels the auroras, but it is also what injects massive amounts of energy into our electrical systems. Our ancestors saw these events as omens or acts of gods. We see them as data points, but the feeling of insignificance they inspire remains the same. In the scientific community, there's a growing debate about the double peak. Often a solar cycle doesn't just have one high point, it has two. We might see a massive surge in activity, a brief period of relative quiet, and then an even bigger surge. If solar cycle 25 follows this pattern, we haven't even seen the worst of it yet. The initial surge in 23 and 24 might just be the opening act. The strange behavior we are seeing, the record-breaking sunspots and the failed predictions, suggest that the second peak could be historic. This is why agencies like NASA and the European Space Agency are rushing to deploy new missions like the Vigil satellite, which will sit at a special vantage point in space to look at the side of the sun before it rotates toward Earth. This would give us days of warning instead of minutes. It is a race against time and a race against a star that doesn't care about our schedules. When we consider the possibility of a black swan event, a solar storm so powerful it happens only once every 1,000 years, the stakes become almost unimaginable. Geologists have found evidence in ancient tree rings of Miyake events. These are massive spikes in radiocarbon that indicate the Earth was hit by solar storms dozens of times more powerful than the Carrington event. If a Miyake event happened today, it wouldn't just be a bad day for the internet, it would be a fundamental shift in human history. We would likely lose the ability to maintain a high-tech society for decades. The fact that the sun is currently acting in such an unpredictable and aggressive way makes the study of these ancient events more relevant than ever. We are learning that the sun has a dark mode, a capacity for violence that we have been lucky enough to avoid during the brief window of human technological advancement. The beauty of the sun is that it is both our creator and our potential destroyer. It provides the light for photosynthesis and the warmth that keeps our oceans from freezing, but it also possesses the power to strip away our atmosphere if it chose to. The strangeness we see today is a reminder that we are part of a larger, living solar system. The sun isn't just a static yellow ball in the sky. It is a complex, rotating, pulsating sphere of plasma that is constantly changing. We are currently living through one of the most exciting and terrifying chapters in the history of solar astronomy. Every new sunspot, every X-class flare, and every failed prediction is a piece of a puzzle that we are desperately trying to solve. As we move deeper into this solar maximum, we must remain vigilant, keep our sensors pointed at the sky, and never take the quiet of our technology for granted. The sun is waking up, and the world is watching, waiting to see what it will do next. Beyond the visible surface, deeper than any telescope can peer, lies the true engine of this solar strangeness, the solar tachocline. This is a thin, mysterious layer where the sun's uniform internal rotation meets the chaotic, swirling outer layers. It is the birthplace of the sun's magnetic field, and right now, something in that transition zone is shifting. Scientists are beginning to realize that the internal clock of the sun is far more complex than a simple 11-year timer. There are cycles within cycles, some lasting decades and others lasting centuries. We might be witnessing the convergence of several of these cycles at once, a grand solar surge that hasn't been seen since the Middle Ages. This would explain why our modern models, which are based on data from only the last 40 or 50 years, are failing so spectacularly. We are essentially trying to predict a 1,000-year storm using a week's worth of weather data. The unpredictability of the tachocline means that the magnetic bundles being pushed to the surface are stronger, more twisted, and far more numerous than anything we've prepared for in the digital age. This intensification has led to the observation of solar tsunamis, colossal waves of hot plasma and magnetism that race across the sun's surface at over 500,000 miles per hour. These tsunamis can trigger secondary eruptions on the opposite side of the sun, creating a global solar event that blankets the entire solar system in high-energy particles. Imagine a star-wide chain reaction where one flare triggers 5 more. This sympathetic flaring is becoming more common in solar cycle 25, making the sun look less like a stable orb and more like a volatile, interconnected web of fire. For those of us on Earth, this means the risk isn't just from a single lucky shot from a solar flare, but from a constant, multi-directional bombardment. It is a level of activity that challenges our very understanding of stellar physics. We are learning that the sun can reset its magnetic configuration in a matter of hours, a process we once thought took much longer. This rapid-fire evolution is the heart of the something strange that has astronomers around the world losing sleep. As we move into 2026 and 2027, the stakes for our infrastructure will reach a fever pitch. In the United States, the Federal Emergency Management Agency and the Department of Energy have already begun simulating extreme space weather scenarios. They are looking at how a total loss of the Eastern Interconnection, the power grid that serves the majority of the American population, would affect everything from water treatment to hospital life support systems. The reality is sobering. Most of our critical infrastructure was built during the Great Calm of the 20th century, a period of unusually low solar activity. We have built a skyscraper of technology on a foundation that assumes the sun will always be quiet. But the sun doesn't care about our assumptions. It operates on a timeline of billions of years, and we are just now realizing that we have been living through a rare moment of solar peace. The peace is over. The strangeness we see today is the sun returning to its true, violent nature. Despite the danger, there is an incredible sense of wonder in what we are witnessing. For the first time in human history, we have the tools to see these events in real time. We can watch a billion-ton cloud of plasma leave the sun and track it as it screams toward our planet. We can see the magnetic loops of the sun's corona dancing in ultraviolet light, revealing the invisible forces that shape our universe. This is a golden age of discovery, even if it is a terrifying one. We are discovering that the sun is a much more social star than we thought, interacting with the local interstellar medium in ways that influence the very edge of our solar system. The solar wind isn't just a stream of particles, it is a messenger carrying information about the state of our galaxy. By studying the anomalies of Cycle 25, we are unlocking the secrets of stars across the universe. We are finding that strange is actually normal for a middle-aged yellow dwarf star, and it is our previous expectations that were the real anomaly. In the end, the sun remains our greatest mystery. It is the source of every breath we take and every thought we have, yet it possesses the power to erase our modern world in a heartbeat. As we stand on the precipice of this solar maximum, we are reminded of our shared destiny. A massive solar storm doesn't see borders or political affiliations. It affects the entire planet as one. Perhaps that is the ultimate lesson the sun is trying to teach us. In the face of a cosmic force that can darken a continent, our petty differences seem smaller than sunspots. We are all passengers on this small, fragile craft, navigating the turbulent waters of a stellar ocean. The something strange happening with our sun is a call to action, a call to innovate, to protect, and to marvel at the sheer power of the cosmos. We will continue to watch, to measure, and to wonder, for as long as the sun continues to shine. The journey into the heart of our star has only just begun, and the greatest discoveries and challenges still lie ahead. We are ready for whatever the sun decides to do next, not because we can control it, but because we finally have the courage to look it in the eye and try to understand its fire.